Okay, hi, I'm back, and so today I'm actually going to be talking about the world of Pandora from the movie Avatar and why the solar system doesn't really that they use don't really doesn't really work once you take a closer look at it. So I guess the first thing to go off with, I'll go with the planet itself. No, not the planet, the moon of Pandora, which is going to be orbiting the planet that they have named Polyphemus, if I'm pronouncing it correctly. And so the main trick with that is that it's around 70% of the mass of the Earth for the moon for the moon Pandora, and that doesn't it's while technically possible, it's very unlikely for it to form in orbit, which would suggest that it was which would suggest that it's a captured planet that it got early on, but that would usually result in all of the other large moons being thrown all over the place in the process of capturing a planet. But they gave the gas giant a large moon system with other large moons in it, which doesn't, while not strictly speaking is impossible, is incredibly improbable. And then I guess next moving on to the actual solar system as a whole. So they the way they, so it what they did works until you realize that because there's another star nearby orbiting around it, or where they're orbiting around each other, they kind of get in each other's way. So like because they get quite close to each other at times because they're very eccentric orbits for the two stars, and as a result, Alpha Centauri A and Alpha Centauri B prevent planets from having stable orbits far away from their stars. Since I think like they can't be past their equivalents of where our asteroid belt would be for where planets can have stable orbits. And so for Alpha Centauri A, where Pandora is, you end up with trying to cram two terrestrial planets and three gas giants into this space, into less space than you have from our sun to the asteroid belt, which, while technically possible, you run into a small problem in the fact that the creator of this setting described the Polyphemus as being slightly denser than Jupiter, while at the same time being around 75% of the radius, which implies a large gas giant, which doesn't it only it doesn't really work in terms of long-term orbital stability. Have that around at the same time as having two other gas giants, because the outermost gas giant won't really have enough space. And the and I know I'm guessing the reason why I thought it was okay because the usual rule of thumb is as long as they're at least a certain outside of each other's immediate gravitational influence, they people usually consider to be fine. But in terms of like long-term geologic time scale stability, you usually want to be around 8.6 times the distance that the people usually put between their planets when they're making their solar systems. And so that's why that doesn't work as well. So in order to make something that actually works, you need something around Saturn's mass, but a fraction of the size, and so you would end up with this weirdly dense gas giant for its mass. And then Alpha Centauri b, they also gave it a even more extensive solar system. It actually has even less space because it's lower mass for the primary star for this one, and they have even more planets. You end up, and it's meant to almost all the planets in this are meant to be an analog to a planet in our solar system, which then runs into some problems because they put in 3 gas giants in this relatively small space. It works slightly better because the biggest gas giant, based on the information given, is the furthest inwards. So that means it will have a smaller area of gravitational influence, which makes things work slightly better in terms of the other gas giants fitting. But you end up with, but the thing that I found odd was that they described the outermost one as receiving a similar amount of light as Neptune, when in order for the planet Poseidon here to get the same amount of light as Neptune, it would have to be way out, basically in Alpha Centauri A's solar system, because that would be around 21 astronomical units, and they have these two stars have a semi-major axis of 23.3 astronomical units and a 50% eccentricity, so there's no way you can actually have something that far out. So everything has to be really crammed in again. And then, just for comparison's sake, there is actually a exoplanet candidate for Alpha Centauri A, which is a gas giant of around Neptune mass in orbit around Alpha Centauri A here. It's on the inner side for the habitable zone, so it's probably not really habitable, but theoretically possible. And yeah.